All right, now we can talk about tests for symmetry and even and odd functions. So there's some specific functions that will have symmetry either across the y-axis or across the origin. So for example, if you horizontally reflect graphs like y equals x squared, so if I do a horizontal reflection, change that by putting a negative on the inside of the function, you end up actually getting the exact same function because negative x times negative x gives you x squared. Well, you can see that graphically as well. If I reflect this function over the y-axis, I get the same function. Same is true for like the absolute value function. So if I plug into that function, it doesn't matter. Like it just does the same thing. And again, you can see if you flex it. So we call those even functions. And I like to remember it because absolute value is kind of a special case, but this is going to happen when you have x to a power that is an even power, then that's going to be an even function. There are other even functions like absolute value, but I like to remember it that like, oh yeah, it's like a parabola, like a quadratic, because x is to an even power, so it's an even function. Because we have even functions, we also might have odd functions as well. So an example would be x cubed, and this one actually gives you the graphical example here, and then I'll show you 1 over x. So if we have x cubed, and then we take a negative on the inside, notice that reflects this way, right? But then if you also apply a negative on the outside, that takes this graph and switches it, and notice that these two are the same graph. So if you have a function that if you do a double reflection and you get the same function, we're going to call that an odd function. Again, let's go ahead and do 1 over x just to show you. Okay, if I do f of negative x, and I plug that in, then that's going to be a reflection this way. And then if I take a negative, I end up getting the exact same function. So these are the official rules right here. They're written above, but this is just kind of how you can look at this, okay? All right, so here's an example. Is this function even, odd, or neither? So this is my f of x. Let's plug in f of negative x and just see what happens. So everywhere I'm plugging in a negative x, where I see an x, negative x cubed gives me negative x cubed. 2 times negative x gives me minus 2x, and that is not the same as the original function. So this is not going to be an even function. Now let's take this one step further. I already know f of negative x, but I could say, okay, well, what's negative f of negative x? Or the negative 1 times what I just found here. And when I distribute that negative, I get x cubed plus 2x, which is equal to f of x. Therefore, this function must be odd.